Okay, in question 31, we have a car parked on a cliff overlooking an ocean on an incline that makes an angle of 24 degrees below the horizontal. The negligent driver leaves the car in neutral and the emergency brakes are defective. The car rolls down the incline with constant acceleration of 4 meters per second squared for a distance of 50 meters to the edge of the cliff. The cliff is 30 meters above the ocean. Find A, the car's position relative to the base of the cliff when the car lands in the ocean. In other words, find X, how far it went. And B, find the length of time the car went through the air. Well, this is an example of a multi-segmented problem, so it's a multi-part problem. We have segmented motion, we have what looks to be constant acceleration in the beginning of the problem, and then projectile motion as the car goes off the cliff. Together, it might look like this. Looking at the picture, we can see that we have a car parked on an incline, making an angle of 24 degrees below the horizontal. And what's basically going to happen is the car is going to speed up and then just go splash right off the edge. And so you're making a first part, segment 1, this is constant acceleration, horizontal constant acceleration. And if I were to draw a path, that represents the motion, we can see straight line constant acceleration down the incline. Okay, and we're treating the incline as though it were a problem that looked like this. So we're treating it as though it were a car starting from rest on a horizontal incline. Part 2 is the projectile motion problem, where it's launched at an angle, and that angle is the same angle as the incline that we're told, 24 degrees. Now, technically, it's negative 24 degrees because it's a clockwise angle. Clockwise angles coming from the horizontal are negative. So technically, that's a negative 24 degrees. But we have a two-part problem. Constant horizontal acceleration to start the problem, and a projectile launched at an angle of negative 24 degrees to continue the problem. So let's begin and start by listing the stuff for the horizontal constant acceleration. So we know that we have this negligent driver. Now it tells you the car rolls from rest. Well, we should know that starts from rest. We should know that phrase by now. And that means, of course, V naught equals 0. We're also told that it rolls with constant acceleration of 4 meters per second squared. And we are told it does for 50 meters to the edge of the cliff. So if the initial position is 0, that makes this 50 meters to the edge of the cliff. We do not know the velocity when it reaches the edge of the cliff, nor do we know how long it takes to get there. One thing to consider: the velocity off the edge, this velocity right here, this final velocity, that's the same as the initial velocity over here off the edge of the cliff. So we definitely want to find that final velocity off the edge. So let's take a look at that. I'm looking for an equation that would help me with this list of variables here find that velocity there. Well, I'm thinking of the only one that doesn't have time in it, and that would be v squared equals v naught squared plus 2a times the quantity x minus x naught. Canceling both v naught and x naught. And if we rewrite this, we get v squared equals 2ax. Square root both sides. And we can see that v is equal to the square root of 2 times 4 times 50. 8 times 50 is 400, the square root of which is 20 meters per second. Okay, so we found that. Now, we're pretty much done with the horizontal part. Now we need to focus on the projectile motion part. Remember, every projectile needs to start off with a calculation for v naught x and v naught y. So let's go ahead and complete those calculations. V naught x is v naught times the cosine of the angle, which would be 20 meters off the edge of the cliff, times the cosine of negative 24 degrees. And v naught y is v naught times the sine of the angle, which is 20 times the sine of negative 24. Okay, pause the video, put that in your calculator, and make sure that you can get that done correctly. When I put that in my calculator, I get, let's see, about 18.3 meters per second horizontally and negative 8.1 meters per second vertically. Now, in this one, it's asking us to find the position of the car relative to the base of the cliff. So we're basically using x equals v naught xt. Now we've got this. We don't know the time. So this might be one of those problems where it's best to look at part B, which in this case it's asking for time, the time it takes that it's going to be in the air, and then come back and do part A. So that's what we're going to do. We're going to hold off on this question here. It's going to be 18.3 times some time. Okay, we need to figure out what that sometime is. Well, let's find the time that it's in the air. So this is part B. We can use the time it takes an object to rise or fall, which would be y equals y naught plus v naught yt minus 1/2 gt squared. We can see by our list right here, we do not know how far. That's actually what we're looking for in part A. We do know v naught x is 18.3 meters per second, and we don't know the time yet. The y we can call 0 at the water line. Y naught we can call 30 meters, which is the height of the cliff above. Vy we do not know as it's about to splash. V naught y we know is negative 8.1 meters per second, and again, time we don't know. Now, again, we can use that equation mentioned just a minute ago to find the time it takes to fall 30 meters. Okay, and if I make that equal to 0, what I can see is I have a quadratic equation with respect to time. So what I'm going to do is I'm going to rewrite this, but backwards. So I'm going to rewrite it. So negative 1/2 gt squared plus v naught yt plus y naught equals 0. Now we can go ahead and plug in some values here. Negative 1/2 g, well, g is 10, so negative 1/2 g would be negative 5, and then of course the t squared, plus v naught y, well, v naught y is a negative 8.1, so this is really minus 8.1 t, and then plus y naught is 30. The cliff is 30 meters high. Well, this would be your A, this would be your B, and this would be your C, in which case we now need to use quadratic formula in order to solve this. Time is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's plug into that. We have negative times negative 8.1 plus or minus the square root of negative 8.1 squared minus 4 times A, which is negative 5, times C, which is 30. All of that is over 2 times negative 5. Time is equal to, well, negative times negative is a positive, so 8.1 plus or minus the square root of, and we're going to have, first we need to do the 8.1 squared, and then we need to go negative 4 times negative 5 times 30. Now, negative 4 times negative 5 is 20, and 20 times 30 is going to be 600. So we're basically going 8.1 squared plus 600. Over negative 10. Okay, that comes out to be 2 possible answers for time. 1.77 seconds and negative 3.38 seconds. Now we can't have a negative time, so this is going to be our answer for how long it's in the air. Now that we have that, that makes part A pretty simple, because we just go ahead and insert that value for time right here, 1.77 seconds, and we could see that the car would end up about 32, almost 32 and a half meters from the base of the cliff.